All right, for our second example of finding the equation for the normal line, we have f of x equals natural log of 2 minus 3x. We want to find an equation for this normal line at x equals -1. I decided to do a natural log function because we don't usually use those, especially for normal lines, and I thought it'd be interesting rather than doing something simple like a quadratic. So let's go ahead and follow the same steps we did with the previous example. Okay, so here is actually our curve for natural log of 2 minus 3x. The orange line is the tangent line. We want to figure out the equation for this red line, the normal line. Step 1 is to plug the x value into the function. So we want to figure out the equation at x equals -1, so we're going to plug in -1 for x. So this is going to be 2 plus 3, right, which is 5. So therefore, the y value would be natural log of 5. So our point will be -1 comma natural log of 5. And it's the wrong graph. So this point is at -1 comma natural log of 5, which incidentally looks like it's about 1.6 or so, natural log of 5. Okay, so that's our point. That's the y value of our point. Step 3 is to take the derivative. So we want to take the derivative of our function. So we know it's going to be 1 over 2 minus 3x, and then multiply by the derivative, so it'd be 1 over 2 minus 3x times -3, like so, which works out to -3 over 2 minus 3x. For step 4, we're going to plug in the x value into the derivative. That will give us the slope of the tangent line, not the normal, so keep that in mind. So we want to find the equation of the normal line at -1, so we're plugging -1 for x into our derivative. Simplify that and we get -3/5. So that is the slope of our tangent line, -3/5. Okay, so the slope of the orange line is down 3 and over 5. We want to find the slope of the red line. Well, obviously it's just the negative reciprocal, or the opposite reciprocal. So if this is -3/5, this must be what? Must be 5/3, right? So I like to look at the graph as we go through this. So again, I got my colors messed up here. I want to color code it to the graph. Okay, so my tangent line has a slope of -3/5. If I determine the slope of the normal line by taking the negative reciprocal for step 5, I get 5/3. So once again, not to confuse you, this is -3/5 and this is positive 5/3. Makes sense because they're perpendicular. Step 6 is to write the equation for a line, y equals mx plus b. Step 7 is to plug in the values. I know my y value is natural log of 5. I know my b value, well, I don't know that yet. I know the m value is 5/3, and I know the x value is -1. So I'm going to plug that stuff in and solve for b. So we get natural log of 5 is equal to -5/3 plus b. Add 5/3 to both sides. And I'm just going to keep it that way because, hey, it's the most accurate. I don't need to find some decimal number. I might approximate it at the end, but that's as accurate as it gets, and that's okay. You can leave it that way. Step 9 is to write out the equation. So you have y equals mx plus b. You're going to plug in 5/3 for m. And again, let's color code this to match the graph. It was red this time for the normal line, orange for the tangent. We get y equals 5/3 x plus natural log of 5 plus 5/3. That as a decimal, I plugged into my calculator and I got 3.27. So perhaps it makes more sense to say y is equal to, or approximately equal to, 5/3 x plus 3.27. And that's exactly what equation for this line is. You can see it indeed crosses about 3.27. That's it for this example. If you have any other questions about it, let me know.